Today we are going to start a new topic, logarithms, which was first introduced by John Napier, and it's a tool to simplify calculations. In maths, log is inverse function to exponents. How? Like if I write 10 to the power, okay, 10 to the power 3 is equal to 100, then in terms of log, it's written as 10 log 10, okay, it's 1000 is equal to 3. So, if in terms of exponents, this is known as base, the power is known as power or exponent, and equal to value, right? So, if we convert it into log whatever is the base for log 2. So here whatever the number is, that is the base, and value comes here. The value which is here as the result, it comes with the log, and that is equal to exponent, right? So first you have to remember this conversion, that how exponents can be written in the form of log. 10 to the power 3 is equal to 1000, and log of 10,000 is equal to 3. So just remember this. We are going to solve some questions based upon this. But let's first see actually log is of how many times, right? So first is the common log, which has many applications in science and technology. Second one is the natural log or the Neperian log. Many applications in maths and physics due to its simpler derivative. Derivative of log of e is 1. So it's used mainly in maths and physics. Binary log commonly used in computer science. Now what is the difference? Common log is log to the base 10. Neperian log is log to the base e, and generally we write it as ln. So if ln is written, that means it's log to the power e, and binary log is log to the base 2. Now if there is no base, then it is assumed that its base is 10 by default in maths and science, and in computer science it's log to the base 2. So it's understood if nothing is written. Now if you see the log tables, they are with log to the base 10. So sometimes if we are using the log table, we need, and we are using the natural log, we need to convert base 10 to base e, right? So what is that conversion? That conversion is, suppose I have log to the base e some number, let's say 54. So you have to multiply it 2.303, and that will be converted into log to the base 10. So if you are using the log table and you are seeing the value log of 54, so that is base 10. But now you have to write it in the form of natural log. So you will write it as log of 54 divided by 2.303. Okay. Now we have learned one rule, that how exponents and logs are inverse functions and can be written as, like, exponents can be written as logarithms. So now we will practice some questions based upon this. Let's say you have 8 squared is equal to 54. And now the question is, you have to write it in terms of log. So let's see the log rule first. So here it is base in the form of exponents to the power exponent is equal to some value, and in terms of log, it's log, whatever the base is, that will come here. This value will be with log, and this exponent is actually the answer. Here value is the answer, and in case of log exponent is the answer. So if we have to convert log, base is base, this value will come here, and that is equal to 2. Okay, so I'll keep on writing some questions. You can just pause and practice at your own. Okay, second, let's say it's 3 to the power 5 is equal to 243, right? So how will we write? Log base is 3, value is 243, that is equal to 5. Let's practice one more question. 10 to the power 6 is equal to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Now in terms of log base will come here. 10, 1, 2, 3, 4, 5, 6 is equal to 6. This is how we convert it. Now let's see certain questions. Like, logarithm is a tool to simplify calculations. So sometimes if we use log, our questions become very easy, which actually, if they are in the form of exponents, they are not so easy to solve. So let's say, for example, my question number one is 5 times 2 to the power x is equal to 240. Now dividing by 5 on both sides, I'll get 240 divided by 5, and 2 to the power x is equal to 48. Now 48 is actually 2 to the power some number, like whole number, is not possible. So how to calculate the value of x? Here log comes. Okay, before applying rule, let's understand one property of exponents. Suppose if I have 2 to the power x and that is equal to 2 to the power 6. Now there is an equal to sign in between, and on both sides our base is same, which is 2. So I can say x is equal to 6. That is the property of exponents, right? Now in my question, 2 to 48 is not any whole number power to 2, right? So now this question is not easily solvable. So here log is going to help us. Now I'm going to apply log of 2 of 48 is equal to x. Now I can check this value in the calculator and write the answer. And we will learn some more properties and we can solve it further. But right now, this is how x can be calculated. Okay, let's see one more question. If you just, give this value in the calculator, x is equivalent to, because there is no exact number for this, so that is 5.585. You can simply write this in the give this into the calculator and you will calculate it. Now let's do one more question. You think it's easier, right? Okay, now second question is 2 times 6 to the power x is equal to 236, and dividing by 2 on both sides, it's 118. Now log 6 118 is equal to x. Okay, now here we can use calculator and write its value, or this can also be the answer. Now let's do one more question. Question is, okay, now let's try some different type of question. 2t minus 3 is equal to 7, right? And so I'll apply log of 10 of 7 is equal to 2t minus 3. I hope you are till now you are comfortable with how we convert exponents into log. So that is log of 10 of 7 adding 3 on both sides is equal to 2t, and then dividing by 2 on both sides. So log of 10 of 7 plus 3 by 2 is equal to t. Perfect. Now let's see some like basic, okay, some exponents. Suppose if I say 6 to the power 0 is equal to 1. This is my exponent. One more question, right? Now how will I write it as log? Log of 6 of 1 is equal to 0. Correct? From here, we can come to a very important conclusion. Any number raised to power 0 is equal to 1 always, right? So, and this number comes as base. So, whatever the base is, log of 1 is always equal to 0. That is a very important, like you can say result or whatever the base is, you can always write log of 1 is equal to 0, because in exponents any number raised to power 0 is equal to 1 always. Okay, now let's do one more result. Let's say if I write 1 to the power literally any number, right? What do you think it is? It will be 1, right? So 1 raised to power any number is equal to 1. Now what I am writing, log of 1 of x is equal to whatever that number is, right? So do you think base can be 1? Because then x will always be 1, right? So if I write log to the base a x, then a cannot be equal to 1. Second important result. These are important results. Log of 1 is equal to 0. And if log of a of x is some log number, then this base cannot be equal to 1. Base cannot be equal to 1. Now let's come to a third conclusion, like let's say log of any base, let's say 0 is equal to x, right? Now I am writing it in the form of exponents. Let's say b raised to power x is equal to 0. Is it possible? Just stop for a while and think. This is not making any sense, right? So in log of a of x, a cannot be equal to 1 and x cannot be equal to 0. So three major results. Log of 1 is always 0. Base cannot be 1 and number cannot be 0. Number with log cannot be 0. So learn these three important rules. I hope till now you are comfortable with the term log and the conversion of exponents into logs or logs into exponents. So in the from the next class, we will learn the rules of logarithm, where the first rule is the base rule. So till then,